Hi, everyone. My name is Ian Gomez, and I'm head of marketing at Grid.ai. We're very excited to be hosting this virtual event today. We have attendees from over 30 countries joining us, so thanks for joining in your time zone. Speaking today will be Luis Capelo, CTO and founder of Grid.ai, and Poonam Chitale, head of product at Grid.ai. A few logistics before we get started. This session will be recorded and will be sent to you within the next day. If you have questions, please ask them in the Q&A tab and we'll answer them at the end of the session. With that said, I'll hand it over to Luis.
Hello, everyone. I'm really glad to have you here. I'm going to be sharing my screens and a few slides, and please let me know if you can see them. How's that looking?
Looks good. I can see them.
Perfect. Thanks, everyone. Thanks, everyone, for joining. I know that it can be really late in some areas. I really appreciate this. Grid is, after everything that has happened last year, Grid became a global company. We have folks everywhere around the world. So we very much appreciate for those who come from inconvenient time zones. So thank you very much for coming. So I want to talk a little bit today about what Grid does and the general problem of how DevOps and MLOps is quite challenging for the development of really advanced AI models, and what are we doing to help you solve that problem. So my name is Luis. I am the co-founder and CTO of Grid. I founded the company together with Will. I'm sure Will, as the creator of Lightning, as I'm sure many of you use. And we created Grid with this idea of we want AI to be, especially cutting edge AI and deep learning, to be used by everyone and to be able to reach production systems as fast as possible and eliminating all of the problems that are in the way. If you're here, you're most likely a Lightning user, or you're thinking about using it. And Lightning is one of the fastest growing open source AI frameworks in the world today. And what it does is that it helps you develop really complex deep learning models without having to worry about a lot of the things that make it really complicated to do. I'm sure if you haven't tried Lightning, please give it a shot. It's a really wonderful experience. The community is extremely active, and we'll be there to give you all the support that you need. Now, I wanted to discuss a little bit about what we're doing at Grid and how Grid complements the workflow that you typically have when you use Lightning today. So if you're developing a deep learning model today, let's say in a production setting, how you go about it is that you have to first identify your problem. Let's say you have a business problem, such as cell detection or segmentation or video segmentation or whichever problem you may have. And then you're gonna find if you have the data or enough data to be able to train that model. And that typically comes before you start developing the specific model for your problem. So now, after you have the data, after you analyze the data and you get familiar with what you have, you want to determine which model you may want to use to solve that problem. So typically how you go about this is that you will read research papers, or identify the latest advancements in technology, or you will find an implementation of those models in the wild. And then this becomes the process of iterating with those models and adapting the models to your own data. So you'll start training on your own data, and this is what Lightning becomes really good at, right? So you start training these models on your own data, and then you evaluate the performance, and then you keep in this loop and this cycle until you find a model that is acceptable and that can solve the problem, can reach kind of the performance levels that you think are very good, and then this becomes the production model. Now, this process is what Lightning really excels at, right? So Lightning helps you not only develop this model in a very structured and organized way, but also it helps you iterate over it really quickly because it organizes things like the logging and provides you a number of tricks to help you train really complex systems or really large models. It also helps you train, let's say, multiple GPUs or multiple nodes. And those are all things that you may want to do when you're starting with a really small model, and then you want to grow to a really large model. Now, the challenge here becomes, let's say, if you want to use a really large infrastructure. Say you're starting your local laptop and you develop a model that doesn't have access to two GPUs, for instance. Now you want to grow this model to have access to 8 GPUs. Okay, that's fantastic. You don't have to change anything if you're using Lightning. Now you may want to have access to a computer. So typically the workflow here is that either you have access to a local machine that has those kind of resources, or you go to the cloud and you start a VM, you SSH into it, and then you configure it, and now you have the cloud, the access to those resources. And that works all right, but now you start to have more challenges. You have to be more familiar with the technologies involved in doing that work. For instance, you may have to be familiar with installing NVIDIA drivers and things like that. And you keep adding new sets of complications to your workloads, especially if you're dealing, let's say, with very large data sets, let's say multiple terabytes, multiple gigabytes. Now, imagine that you want to do this, but you want to do this at scale. Say you want to run a hyperparameter optimizer, or you want to run a hyperparameter sweep. You want to try 50, 100 combinations of your model, and each one of these experiments require, say, 4 GPUs, 8 GPUs, 16. Now, having to do this process of having to start each one of these machines becomes prohibitively time-consuming and error-prone, of course, and it just becomes also very expensive for you to do, because just setting this up manually just takes so much time that it becomes so expensive with these kinds of workloads that it's not worth doing it. So this is exactly the area that Grid is working to solve today. So we help you, especially folks that have been developing these kinds of models and have suffering with these kinds of problems, to not have to worry at all about any of this orchestration of resources. And we'll do everything automatically directly inside your cloud account, so that you can very quickly iterate and find the right model. And then whenever you have that model, you can send it to production, and then work with your colleagues to monitor, evaluate, and retrain whenever possible. So the idea here is that you can very quickly iterate through massive infrastructure and massive models, and just find the one that best fits your problem and get going with it. So this is how we think about this in a bit more of an abstract way. We want to first solve your MLOps and your DevOps problems, so that you don't even have to think about it. You don't ever have to visit the dashboard of your cloud provider at all. And also, we want you to be able to collaborate with your colleagues in a more effective way, so you can see what your colleagues are running and what your teammates are running in terms of experiments, see if other models are working well, be able to track their artifacts effectively, and also be able to track cost utilization and resource utilization, see the things that are available, so that you can more effectively collaborate as a team. So this is where Grid sits in this problem area. So you work directly with the solutions that you're familiar today and that you love. So you work directly with Lightning, and then Grid connects directly with your cloud providers and serves as a gateway to it. So you say, hey, I want to run all these things, and I want you to figure out everything else. And now the magic here is that Grid does not require for you to change anything at all in your workflow or in your code. So if you're using Lightning today, or PyTorch, or TensorFlow, or anything else, we don't require you to change anything. And I'm going to give you a demo later today to show you exactly what this means. But I think that the magic here is that Grid goes straight from what you can do locally to hundreds of machines in the cloud without forcing you to change anything in your code. Okay, so I wanted to pass the word to Poonam. Poonam is our head of product, and she'll be describing kind of the main areas of Grid today. And later on, I'll come back to show you a demo on what you can do with Grid today and how can you use our community edition of Grid to give it a try. So please, Poonam, take it on.
Thank you, Luis. Hi, everyone. So I wanted to go over how does Grid help with MLOps. We saw what MLOps challenges are, and we saw the challenges that Grid is trying to help with. So if you think about a machine learning researcher or a data scientist, really they're concerned with data and algorithm, and then training that model and then iterating through it again and again until they have the best model. So what Grid does is Grid helps with machine availability, be able to scale these models for large scale training. Let's say if your model doesn't fit on a single GPU, then we make all these multiple GPUs available to you so you can quickly scale these models. So orchestrating of that infrastructure for the ML researchers so that you don't have to do anything. Then there is data availability, which is a biggest part of machine learning that can really become a bottleneck if you have to keep downloading or uploading new data all the time. So just as PyTorch Lightning helps with modularity of algorithm and data, decoupling the science from engineering, the Grid platform helps with optimizing the data availability and machine availability for model training. So it decouples the ops part of MLOps and optimizes it or accelerates it, if that makes sense. And then the scalability aspect of the platform is such that you can start from one GPU or even one CPU and then use as many as 16 GPUs to speed up the training of large models. The GitHub is a common source code development platform, and we make sure that when you are using your code and scaling up to the cloud, it's extremely portable through the machine learning iteration, through the iteration of training. So on the next slide, let's talk about the three different areas, the three different sub-products within the Grid platform. So these three areas are the ones that we have available in the Grid platform and really allows the machine learning researchers to focus on what they are doing and not worry about infrastructure. Data stores are really data sets. So large amount of data is needed to be available for machine learning and deep learning models. And fast availability of this data for model training or debugging reduces the overall development, debugging, and the training time. So with Grid, we allow you to create data stores using a command line or a web interface. Now, data stores is our term. We call it data stores to make sure that people can actually upload their data sets and either through a URL or through a file system, and then have it available for them whenever they are debugging or whenever they are doing the model development training iteration cycle. So there is a command line interface and there is a web interface for you to be able to do this. And keeping track of updates to the data stores, for example, doing periodic timer-based uploading whenever the data changes. All of these features are really advantageous to speed up your overall training process. And best of all, you can associate data stores with your sessions, with your interactive sessions or training runs. So let's talk about sessions next. So sessions are cloud virtual machines. Sessions are cloud virtual machines that Grid allows you to create one. So when you create your own session, you are asking Grid to make machines available to you that have multiple GPUs. And then Grid allows you to access these with Jupyter Lab or SSH or VS Code, your tool of choice. And when you have created this with a data store mounted, then when you start this machine, that your data store is available to you. You can browse the data sets in it. If you wanted to upload new data sets, you can do that. So basically everything you can do on a laptop, you're now able to do that in a really powerful cloud machine where you can carry out multiple debugging experiments that you want. So there are several common utilities that a data scientist needs or machine learning researcher needs, and these utilities are pre-installed. So you can take advantage of that, and you don't have to spin up a new environment. You don't have to start from the basics, so to say. And obviously, there is a lot of flexibility. You can continue to do installations on that and work as if you are working on the cloud machine. And best of all, you can pause the session, and when you resume, you can start wherever you left off. So this is a very attractive feature for the researchers that we have been talking to, because that allows them to keep track of costs. Not only it saves money, so you can pause the session, big 8 GPU or 16 GPU session, and then resume where you left off. So you're saving money and not having this machine sit idle. But it also reduces the impact on the environment doing this. So now let's talk about runs. So the runs are designed to be frictionless. So when I speak about runs, it's really the model training runs. Any GitHub scripts. We know that the machine learning researchers, they love to use open source. Obviously, many of you are familiar with PyTorch Lightning or PyTorch or any of these open source frameworks and open source development areas. So what Grid does is it allows you to run any GitHub script, public or private repository, on the cloud straight from your laptop. When I say that it allows you to run straight on the cloud, what does it mean? You don't have to do any code changes. You are just scaling this training on the cloud, and Grid automatically makes certain parameters and things available to you. So you can run large hyperparameter sweeps. You can do either grid search or random search. And it really allows you to develop these large scale applications leveraging your research code. So on the next slide, you will see what I mean by training on the cloud with zero changes. So here is a GitHub code. Here is a simple PyTorch Lightning GANs model. And now you are able to use that same script, just copy and paste it and saying a new run in the Grid platform in the web interface. And you're able to scale and use the GPU processing power to conduct all your complex computations on the cloud. So overall, there is this optimization and leveraging aspect. And what I mean by that is you scale your training, you are able to leverage your GitHub code. You can really optimize and leverage all available resources. So what I mean by that is ability to use your own cloud credentials, for example. So you can continue to use Grid platform with your own cloud credentials. So this is something that Louis will go into a little bit of more detail later on in this presentation. The other thing is being able to use the interruptible instances. So these are typically called spot instances, where the instances, they really lower the cost of training for you, but they can be interrupted. That's from me. I just gave you like a high level features of Grid and what the product consists of. So now I'm going to hand over to Louis for a demo.
Thanks for that. I really appreciate it. Yeah, so I wanted to give you a demo of what we do today of all the products that you've seen. So I'm going to be sharing my entire screen. Let me see. Can I get a thumbs up from folks to see if does this look good?
Yeah, that looks good.
Yep.
Awesome. Yeah, here's what you can see today at the Grid Community Edition, and I'm going to show you how it will work if you were to link your own cloud, which is really where the magic of Grid happens. But all of the features here are available in the Community Edition, so you can try everything today if you come and create an account on Grid. In summary, Grid consists of this two large things that you can do, right? So you can create runs, which are a collection of experiments, or you can create sessions, which are this interactive VMs that contain a bunch of utilities. Now, we always keep track of everything you're doing and everything your team's doing if you're using enterprise, so that you can have kind of an overview of what's currently happening and how much things are costing. Now, the first thing you most likely want to do in Grid is you want to link your GitHub account. And you have two options. You can link your public repositories or private repositories. And of course, in private repositories, you can choose which organizations you want to give Grid access to. Grid can easily clone the repositories and do things with it. Now, in our Enterprise Edition, what you can do is you can link your own account. What you can see here is that I have two accounts linked. Let me just change it from light mode. And this means that I can schedule workloads in any of these cloud accounts without ever having to log into AWS or do any of that stuff. And how does that work today? So you already have a session running. So how it will work is that, let's say I have my cloud account linked and I want to start a new session. I can give it a name. If I have a data store that I want to mount, I can choose it here. I can choose which cloud account I want to start the session in. And then I can just, and the session will start in a few minutes. Now, what I wanted to highlight is that we provide support. Let's say in this case, we're running AWS. This account is AWS. We provide support for all of AWS GPU instances, plus a number of CPU instances, which we think are useful for each develop work, but we really prioritize GPU workloads. So you can see that I can start an instance that has 8 V100s, for instance, with 32 gigabytes. And we do all of the work on installing the drivers, installing all the utilities there, so you don't have to do anything at all. Now, one of my favorite features of starting sessions on Grid is that in addition to the usual, you can have GitLab, and GitLab comes with a bunch of utilities, so you don't have to do anything. You don't have to worry about anything installed there. One of my favorite features is that Grid comes with a fully featured SSH gateway, which means that you can SSH your instance and use everything that you like. For instance, if you like using our sync, you can do that. Or, which is what I like the most, is to link VS Code. So we have full VS Code integration. So in this case, you can see that I am connected to this session called Fervent Orca 321. And I can have access to exactly what is inside that session. So here I see I cloned this repository, and I'm developing this model, and this model is exactly what I have here. So I can just work in my local workstation directly and have it reflected remotely. And of course, this also has full access to SSH and a number of other really nice utilities, such as, for instance, this is a private repository, and or sessions automatically log into Git for you. So you can clone this repository and get going with it. So whenever you're done working in sessions, especially if you're using sessions that are really expensive, you can pause them and we'll preserve all of the files that you've been working on that session. So that means that, let's say, if you're running something that's really expensive, you can pause it overnight and just restart the next day and just keep going with what you want to do. Now, I mentioned a little bit of data stores. Now, a common problem is the following. Imagine you're training a model that requires access to a very large data set, say a terabyte. And you wanted to have that data set accessible, let's say in a session. What typically you would have to do is that you have to create a VM, or in this case a session, and you want to download that data there and process it. And even with pausing, which is great, you still have to do that the first time. But what if you want to change your session? What if you want to have more GPUs available? Now, you're going to have to repeat that process. And with a very large data set, like a terabyte, it just becomes this non-trivial operation, right? You just spend a lot of time doing that same work over and over again. So we create data stores to solve exactly that problem. So when you create a data store on Grid, these are version packages of your data that are highly optimized for deploying workloads. In this case, I have a small data source in this example, but data stores support multiple terabytes out today. And what you can do is, and in this case, I can create this, for instance, crypto prices data store, and I can mount it in any of my workloads, either experiments or sessions. And when I mount a data store into a session, what happens is that data, we create a highly optimized volume and mount it directly to the session, which means that you're not paying the penalty of having to download that data over the wire, and it becomes this immediate access to the files in your file system. Now, the good thing is that data stores are also versioned. So let's say if your data changes frequently, say maybe daily or once a week, you can automatically create new versions of this data, and you can mount the newer versions to your sessions and experiments and not have to worry about having to re-download and process data. Now, imagine that you now have created a data store and you've developed a model, you've identified a version of your model that you want using sessions. So in this example, I'm working on this simple experiment using a great package called PyTorch forecasting, which is built on top of PyTorch lining. And the problem that I'm trying to solve there is I have a series of cryptocurrency prices, and I want to see how well can I create a model to predict prices using common cryptocurrency market indicators. So I have used a session to develop this model, and I created this very simple script and very simple class. And now I'm ready to train this model, and I create kind of the simple interface. So I can train the model on the sessions without issues. But what I'm really interested in doing is to creating a hyperparameter sweep that tries many combinations of hyperparameters so that I can find the best model possible for this data. So what you can do with Grid is Grid specializes in solving exactly that problem and makes them extremely easy to do. So this is what we call runs. Let's say you wanted to do that today. Here I have my private GitHub repository with this example. I can copy this link, to show you how this would work as an example. And I can create a run. And as soon as I click there, you can see that the Grid will automatically read the repository and identify which branch you want to run, or you can specify a specific Git cha. You can give it a name. I can mount my data store there, choose the version. I can even choose where exactly I want to mount it so that my script can read from it in case your script is expecting the data to be available in a certain location. And then you can choose, of course, in which cloud instance you want to run, which node, which kind of instance type you want to use. And then, of course, you can pass the parameters to your script. So in this case, say, I want to use just learning rate. Great. So this will create one experiment. Now notice that Grid, you don't have to worry about building containers or choosing which drivers to use, any of that stuff, because Grid will do everything automatically. It will introspect your repository. It will identify which dependencies work best, and it will install the right dependencies. And we provide a simple pre-built set of dependencies, in this case, lining, so that you have a fresh start. And it keeps that concern away from you. So you can just very quickly just start the workloads. Now, when you do this, there are two really great features. One of that is in beta, which is the ability to choose preemptible instances, which all of the instances that Grid supports, they're also supported as preemptible. So this means that you can have your same workloads be much, much cheaper than if you're to use on-demand instances in your own cloud account. But of course, with the risk of having those instances being taken away, yet this is a perfect fit for hyperparameter sweeps. Like you want to try just a large combination of examples so you can use spot instances just with that click. And then you can see that the cost that we estimate is much lower. Great. So whenever I run that, the experiments will start running, we'll spin up the machines, and they'll run as you specified. And there are a couple of things that we do that are just take the worry away from you from having to integrate with a specific platform. Let me tell you what those are. In this particular script, imagine that I did not change anything. There's no integration with Grid. This is a script as is. So I can go to a public repository, let's say from a newly published paper, something that I have not developed in any way, and I can just choose a script and run. And what Grid will do, in addition to orchestrating the infrastructure, Grid will automatically parse any TensorBoard logs that are created, and will display them on Grid in near real time. And this gives you kind of this ability to not have to download the logs and start TensorBoard. You can quickly glance of how your models are doing. Also, you don't have to specify anything for a specific directory. Grid will automatically observe the entire file system and notice changes. And we have this two-way sync, which means that if you delete something locally, it will also be deleted from your cloud bucket. Otherwise, everything is fully synced. So it means that all the checkpoints are automatically stored, so you don't have to worry about storing things in a specific location or versioning them. And which is cool about that is that you can also, we provide this shareable links. So you can take a link of your checkpoint, and this link will be made public for just a few minutes. So you can share, let's say, with your colleagues, or you can download it if you wish. And all of these operations is fully supported in the CLI. So if you want to choose the CLI or the API directly, you can do that too. Now, imagine that and of course, we provide full integration with TensorBoard before I forget. And the way we do TensorBoard today is that you can choose either a combination of past experience and current experiments, running experiments, or any combination that you want, and you can start a fresh TensorBoard instance, and the logs automatically be synced with TensorBoard. And this is really neat because, say that I have an experiment that I ran last month, I have an experiment that is running right now, so I can combine both experiments in the same TensorBoard instance and compare how they're doing without having to find artifacts or TensorBoard logs or anything like that. Everything just works very seamlessly. Okay, so the last thing I want to show you is whenever you successfully run something, Grid is all about reproducibility. So we provide you with this really handy badges that you can add to any of your, let's say, documentation systems or GitHub. And when you click on that badge, you can fully reproduce that same run. So the idea here is that it's very easy for, say, when you publish a paper or when you reach a certain result, for you to add this little button in whichever documentation you want so that anybody else could reproduce the same results. Now, I've been talking about hyperparameter sweeps a lot, right? And what I want to show you is how we're solving that problem without you having to modify your scripts in any way. So Grid created this syntax for you to be able to run hyperparameter sweeps without having to modify your script. And the way by which we do that, it's say we take a parameter that you want to sweep on, let's say learning rate, And here I have a single parameter. This will yield one experiment. So we introduced a syntax in which you can sample from a number of NumPy distributions. Say I want to sample from the space of 0 and 0.001, and I want to sample 10 experiments. And you can see that Grid now automatically identifies that you're running 10 experiments here. And Grid will automatically assess the cost of this, will pass the values sample from this function into each one of those values, into each one of this arguments for your script, and we'll combine them. So you can combine different things. You can combine the sampling from NumPy functions or simple Python lists and expressions without having to modify your script at all. You can take a paper that was just published and try it in your data and try different hyperparameter combinations with zero code modifications. So all of the features that you see here are currently available in the Grid Cloud. So we encourage you to come and use the community edition. The enterprise offerings include more advanced features such as Steam management and the ability to link your own cloud account. So if that's something that it's interesting to you, please reach out. And I'll be happy to answer any questions if you have them.
Yes. So Louis and Poonam, we have a bunch of questions that came in. Thank you for the presentation and thank you for the questions from the audience. All right. So one of the questions are, as an ML researcher, I spend a lot of time prototyping my models, specifically performing small runs that require 1 to 2 GPUs and iterating on the model specification. Second stage includes a hyperparameter search, etc. How easy is it to prototype with Grid.ai?
So I think we designed Grid exactly for that workflow. And so how I would go about it is, at first, I would develop it on a session, an interactive session. If you have a very large data store, I will create the data store so you have it already available. And then whenever you have the right model definition, you can very easily create a run, a collection of experiments straight off the session, or using the CLI, or using the web UI if you like. And that will help you train models for a very long time in a very cost-efficient way and find the right combination of parameters to your model. So that's exactly the use case that Grid solves. Moreover, if you use our enterprise edition, you can run all of that inside your own cloud account, which means that no data leaves your cloud account. Grid works as a proxy, as a window to what's running inside your cloud account, but everything remains inside your cloud account, including your artifacts, your data, everything remains there. So yeah, with Grid is exactly designed for use case.
Awesome. Next question is pausing a Grid session different from stopping an AWS EC2 instance? Asking because when we stop, we still have to start from scratch.
Yes, actually, sessions are a little different than, and this is a great question. So if you were to go to AWS and you, let's say, start an EC2 instance, which is a VM, and you modify things on the file system, and you can hibernate them. If you stop them, you lose the data. Now, if you hibernate them, you're able to restart it from the data where you had. Now, Grid works differently because Grid will preserve all the data that you store in your home directory in sessions. What that means is that you can store any data, and that data will be preserved, and you can use, when you pause a session, that VM is thrown away, so you don't see it anymore, but we keep the data. And whenever you start a new VM, we restore the data into that session. So why is this useful? So in the case of EC2 native functionality, sort of your data is attached to a certain instance, but in our case, the data isn't. So what you can see today is that you can pause and restore sessions, but we have this great upcoming features that you can, for instance, pause a session, and then you can move data to a different session. So you can start a different session with a much more powerful instance, say, and restore that data and kind of get going that way. So I think there's a different design philosophy there. The goal for a session is for you to always have your files then, and then be able to mount them in different actual VMs as you need it.
The next question is, can we use Grid locally instead of any cloud?
Yeah, that's a great question. Actually, if this is something that's interesting to you, please reach out to us because we're looking for more use cases. So Grid is designed. So the idea of Grid is that you can orchestrate any resources with the same interface. So it's right now the immediate support for cloud operations, so you can link your cloud accounts and Grid can orchestrate workloads there. However, we've been working really hard to provide support to local clusters too, meaning that you have either a single computer that has GPUs, or you have a small cluster, then or of any size, then you can install Grid in that cluster, and that cluster will be available with a Grid interface. So it means that kind of in the same interface, you can say, oh, I want to run stuff on AWS or GCP or in my local cluster, and see everything under one roof. So yeah, that is something we're working really hard to provide a great support for. And if that's something that you're interested in, please reach out to us.
Probably a question for Poonam. Does Grid support Azure?
Yeah, that's a good question. It's coming soon. Our objective is to support all clouds, and yes, if you are interested specifically in Azure, please get in touch with us. And the support, we're working on that support.
Awesome. Next question. I'm curious to know, how does Grid enhance our decision on selecting the best model? Is there a minimum number of iterations required for Grid to recommend the best model? Would it be possible to go over such an example?
Yeah, I think this is a good question. So Grid would not recommend you a best model today. I think what we will allow you to do is to make it really easy for you to train very large combination of models. And then as we move along, we have plans to integrating better, more advanced systems for you to figure out how to choose these models, including visualizations and so on. But it's really up to you to decide which models perform best. What we will help you is to take a look at your metrics and make that really easy, or to compare the metrics from many different models, including recent and old training sessions, so that you can find the best thing. But I would say, let's say your use case, can you still see my screen?
Yep.
So let me just give you how that would look like. Let's say, oh, let me see. Oh, never mind. But let me see in this example. So if you wanted, if you wanted to go about your model. So if you haven't tried, we have this fantastic project called Aligning Flash, which is a new project that makes it really easy to train new models with best practices. And Flash is built around the idea of tasks. So you can have different tasks that does different common different operations, such as you want to do text summarization, or you want to do object detection on an image. So it's really cool. So let's say that you wanted to find which best model works here. For instance, in a problem like object detection, Flash adds support for a number of common backbones like ResNet 18, ResNet 50, and so on. So what you could do using Grid is that you could create a hyperparameter sweep in each one of the backbones that you want. Say I want to try ResNet 18 and 50 and 100 and so on. And I want each one to train for several days. So Grid makes that really trivial. So you can develop your model in a very small network, say ResNet 18, and then you can run a hyperparameter sweep in all of the combinations of the backbones of Flash, and that will help you find the best model, so you can compare the metrics of that model. I hope that answers your question.
Thanks, Louis. Our next question is, oh, go ahead, Poonam.
Just wanted to add to that. One of the aspects that we have heard people, they really like about Grid is the ability to visualize the metrics. So after you have started when you start your model training run, like using either the Lightning Flash repository or any of those. Yeah, exactly. So being able to visualize those metrics and understand where your model is improving or not is very useful to researchers. This is what they have told us. So if you want to experiment with hyperparameter sweeps, your code is your own code, right? Like you can work on it on GitHub, and then you can rerun these experiments to see how you're improving.
Awesome. Another question was, can you explain in a bit more detail how data stores work?
Yeah, of course. So data stores, let's say when you link your cloud account and you want to create data stores, what it will do is it will take the package, let's say a collection of files, you point it to a directory, as an example, and this directory may have hundreds of thousands of files, and we'll create a package from this directory, and we'll then upload this package to your own cloud account, and we'll put it into a safe location in your cloud account. And then we'll take that package and we create a highly optimized volume that then we mount to whichever using your sessions and your runs. The magic of doing this is that every time you want a session, every time you want to run, we don't share the same volume. We sort of create copies of it, and then we mount that to everything that's running. And the reason why this is a better technique than having to download or access data directly from, say, S3 is that these are much faster to access. They're exclusive, so meaning that you're not suffering from common problems like NFS, having to access the same NFS server. And also they're immediately available for read operations. So as soon as they're mounted, you don't have to wait for anything to download, anything to be processed. It's just immediately available. And then whatever you're not using, let's say if you don't have a running experiment, then those volumes are pruned, like those copies are not around. So you don't have to worry about like wasting resources on things you're not using. I hope that answers your question.
Awesome. What are the advantages over using AWS SageMaker?
Yeah, that's a great question. I think from a product feature perspective, there are a couple of things that really work better than SageMaker. One is SageMaker would typically require you to modify your scripts and workloads to the way that they've done to create things. So you have to use the SageMaker SDK and other limitations like that. So you have to develop your script to match what they want. And this can be a lot of work depending on what you're doing. So say I want to implement a new paper, or let's say, as an example, OpenAI published a new paper and I want to run this paper with my data. So that can be a really arduous work because now I have to develop that paper on SageMaker. But assuming that work, you're familiar with it and you become a professional at it, so that's not a problem, you can move on. The second challenge that we're trying to solve is the idea of lock-in. So if you're using SageMaker, then you can't use GCP, for instance, or Azure, or even your local cluster, or your laptop. So the idea is that with Grid, you just, the script remains as is. You don't have to modify it in any way, and Grid will do everything to run the exact same workloads in any cloud provider. And lastly, I think the one thing that I want to say about SageMaker is that I think I personally find the experience of SageMaker very cumbersome to use, and Grid is really keen on providing a very clear and intuitive user experience, so we're never in your way. Sometimes it feels like SageMaker is always keeping me from doing stuff, so Grid tries to make that as smooth and trouble-free as possible.
Great. Another question is, how can we collab with our team inside the Grid environment?
Yeah, I think that's a wonderful question. Maybe Poonam, could you take this one?
Yeah. Today, when you use Grid, the way you can collaborate is you can download artifacts when you train your model and you generate all these checkpoints or hyperparameter configuration files that you used, you can download them. We provide those links, and those links are active for at least 24 hours, and you can share them with your team. The other way is if you wanted to share a run with your teammate. Let's say you conducted a run and it was a successful run, and now you want to share this exact run because you're showing it's reproducible. So you want to share it with your colleague. You can simply copy and paste that into email or a message, instant message or something, and you can share it with your colleague. And as long as this teammate has the same platform, they would be able to run that same experiment and get the same results. So that's one aspect of collaboration and teams that's already there. There's also cloning of runs. You can clone runs by just clicking a little icon in the new run box. There are much more features for teams, like to be able to collaborate seamlessly with your team, and that is a different product. That's like an upgraded product, and if you are interested in that, like, then get in touch with us, because it's different, because you are working in a team. You can add your teammates, and then you are able to like share your runs with everybody in your team or certain people in your team. There are multiple aspects to a team's product, and which is a different product within Grid. And so if you're interested, you please get in touch with us so we can add you to our early access program.
Thanks, Poonam. Next question. Do you plan to support AWS code commit and GitLab?
That's a wonderful question. The answer is yes. Yes. Now, as per, will depend on the roadmap, a few things. Of course, we start with GitHub, which is the most popular source control, and then other Git providers such as GitLab, Bitbucket, and so on. And then if there's a use case that you're interested in, we'll love to provide support for the code commit product from AWS. And that's something that we do have in the roadmap, but depending on user demand, we'll add more Git providers. So if it's something that's specific to your use case, we'll love to hear more about it. But the answer is yes, we want to provide support for as many hosted Git solutions as possible.
Great, thanks, Louis. If in my runs, I expect to generate lots of data, like new videos, how do I access it locally and share it with my collaborators?
Yeah, so I think, so this is a common problem actually that we're solving. Grid automatically observes the file system, and any modifications to the file systems are reproduced and replicated in your cloud storage. So either S3 or Blob Store in Azure and so on. And what this means is that, let's say you generate things and you can delete them and so on, and they're reflected in the same way in the cloud storage. Now, what your collaborators can do, if they're part of our team's product, they can have access to your artifacts. If not, if you're using the Grid Community Edition, it's only you. But what you can do is you can, using the Grid CLI, you can download those artifacts. So it's very easy for you to say, sync the artifacts or re-download it every 5 minutes or whichever interval you want, and keep a good track of what they're doing. So a common workflow that we've observed is that you can start a session, and then let's say from the session from your local CLI, you can start a collection of experiments. And then in the session, you can then download the artifacts from whichever runs you have. And this allows you to both see, let's say the videos in your case, oh, I want to just see if the videos are doing well, or you can do more complex analysis. Say, you can take the checkpoints of your model that is in training, right? And then you can load it into a session and do more advanced analysis there. Let's say you want to run certain predictions in certain data sets. So Grid allows you to sync these artifacts to any location that you want and observe them in real time as your training is ongoing.
So, are there any offers for students and a small team of students?
Yes, the answer is yes. And please get in touch and we'll love to discuss in more detail.
Is Grid able to run ML pipeline components in parallel on the same or multiple computing devices?
ML pipeline components. So I think we don't understand the question very well. We're talking about model training iteration and running hyperparameter sweeps and things like that. Maybe we need more clarification on the question.
And they had a follow-up, sorry. Does Grid support DAG for running pipeline components?
Yeah, that's a good question. Do you want to take it on, Poonam?
No, I think it's difficult to answer this question on the in the live format. I think we probably need to dig deep and understand use cases to be able to answer questions like that.
Yeah, I do want to just touch on kind of the sharing of resources. So Grid would automatically, depending on, you can allocate these resources from the specific instances for specific experiments, which means, as an example, if you could start an instance that has 8 GPUs and you can tell Grid, oh, I want this instance I want 1 GPU to be allocated for experiments. So what Grid will do is it would automatically figure out how many experiments can fit in that instance and how many instances you need in order to run those experiments. So it will not leave, let's say, resources idle if you don't need to. Long story short, it will share the instance if you tell it to do so. Otherwise, you can say, no, just use all of this instance per experiment.
Awesome. And then we're right on time. And then Lewis, if you just want to show the next slide, please. And here's how you get started with Grid, with our community edition, grid.ai/pricing. I also put the link in the chat. And then next slide, please. And join our Slack community. And there's a link there. And I put that also in the link in the chat. And we'll also send it in the follow-up email with the recording of the slides. And with that said, thanks everyone for joining today. Super excited to be hosting this virtual event with Poonam and Lewis. Thanks again. And look forward to more of these events and stay tuned. Thanks, everyone.
Thank you.
Thank you.